Okay, welcome to Standing for Truth. I am your host, SFT, and today we have the privilege of having Michael J. Oard with us. Mike has been here 3 times before, and so this will be his 4th time on the show. Mike, thanks so much for being so generous with your time.
Oh, you're welcome.
I appreciate that. Now, for the audience sake, and we just hit our 5,000 subscriber mark, so we got a lot of new viewers. So please check the description box for the previous shows that we have done with Mike. The first show we had with him was months ago, titled "Astounding Evidence for the Flood." Then we had a must-watch presentation on the Ice Age, and just a month and a half ago, we had Mike on for a show dedicated to debunking evolutionary challenges. So all must-watch shows, please check those out. As I said before, they're listed in the description box. So before I hand it over to Mike, George, you are our co-host today. So thanks for being here, brother.
No problems. Thanks to Mike for coming along again. And we'll probably have another series of questions for you, Mike. But standing, it's 5,160 subscribers.
Awesome. So
don't forget those
right
160. Yeah. Not right now. No, total.
Oh, okay.
So that being said, everybody in the chat, thanks so much. Please, as you are already doing, tag me with your question at Standing for Truth. That way I won't miss it. We've already got a ton of questions that have come in, and also questions from previous shows that we just didn't have time to get to. So it's going to be roughly an hour and a half to 2 hours, and time is going to fly by with all the information that is going to be coming out today. So that being said, Mike, I'm going to hand it over to you if you wanted to give a brief introduction and kind of get right into it.
Okay, I was asked to do a question and answer, but then I was asked to talk a little bit about the origin of Grand Canyon and how do you explain scavenged dinosaur bones early in the flood. And I'll add that I'll talk about tracks, dinosaur tracks, and dinosaur eggs about the same time. In order, each one of those presentations are about an hour apiece. So to allow a lot of time for questions and answers, I'm going to be very brief. And hopefully I won't snow the audience because of it being brief. But anyway, I believe that Grand Canyon was formed by late flood channelized erosion, cutting rapidly through those plateaus, the Kaibab Plateau being the top one. Creation science or flood geology is sophisticated enough to have more than one theory on the origin of Grand Canyon. The other one is the dam breach hypothesis or theory. And I believed it at one time, but then I looked at Grand Canyon. I floated it twice, hiked down it, been at the rims many times, and I soon this. And by the way, I've been studying Glacial Lake Missoula and the Missoula flood, and I saw a lot of features that didn't make sense for a dam breach. So, with time, I mentioned them in 1993, and I hope that advocates would do research on them and solve these issues, but they didn't. And the more I thought, the more I realized, hey, it has some fatal problems and should be rejected. There's actually, I think, 4 fatal problems. Actually, there's about a dozen problems from the point of view of a dam breach. A 4th one that's not listed there is that at the entrance to Grand Canyon, where the lake's breached and eroded 1,000 cubic miles of hard rock, you should have a monstrous delta with big rocks at the mouth of Grand Canyon, and you have nothing of the sort. There's no delta. That's a 4th fatal problem. But anyway, I'll talk mainly about these 3. No evidence of the lakes. You got to have lakes to have a dam breach, and this is all after the flood, by the way. And it should have breached at low points on the Kaibab Plateau, and the low points are about 5,700 feet on the northern edge of the Kaibab Plateau, and about 6,400 feet on the southern edge. Well, it breached at 7,200 feet on the south rim and 8,200 feet on the north rim because it slopes down to the south. So that's where it breached at intermediate altitudes. The height of the Kaibab Plateau is about 9,200 feet. That's the highest point. So I probably won't say too much about that second point, but I'll make talk a lot about no evidence for the lakes in the long tributary canyons. Anyway, we have a lot of lakes in Southwest United States during the Ice Age, right after the flood. They were probably, this is in the Great Basin. These are enclosed basins with no outlets. And there's even more so down in this area where Death Valley is. There's a lake 600 feet deep. So this is an incomplete picture. I need to replace it, but I haven't had time yet. But anyway, we had a lot of big lakes and right after the flood. And they were filled up with floodwaters, first of all, and then they continued to rise because of the heavy precipitation during the early part of the Ice Age. So, and then what they do, these lakes form shorelines. This is the shoreline of that big lake. Several of them at several levels along the hills around Great Salt Lake in Utah. They're all over these shorelines. And lots of shorelines from these lakes. Here's one in southeast Oregon. They're pretty low. The lake was pretty shallow there. But we see shorelines with these lakes. We should see shorelines with the two lakes that were supposedly dammed up by the Kaibab Plateau. One's called Lake Hopi, and the other's called Canyonland Lakes. One's to the northeast of the Kaibab Plateau and the other southeast. And so we should see shorelines, but we don't. There are no shorelines. And here's shorelines from Death Valley, by the way. 600 feet deep lake in Death Valley during the early Ice Age. And here's a shoreline. We know it's associated with the Ice Age because here's a shoreline. I assume everyone can see my cursor. Right there on that end moraine coming out of the eastern Sierra Mountains, when Mono Lake, which is mostly dried up lake, was 700 feet deeper during the Ice Age. So lots of shorelines. And then Glacial Lake Missoula, where I live, near where I live, it broke through this ice dam, filled up Glacial Lake Columbia, and then spilled down through this green area here, eroding 50 cubic miles of hard basalt, the green area, and light silt, which has been eroded, which is kind of a light green area in this. And there's shorelines around Glacial Lake Missoula, really obvious ones. I think these are 1 year shorelines where it raised, and you got to preserve those shorelines below. So by raising it, you preserve the one from the previous year. So, but after it got to the top, 1,000 feet deep at Missoula, Montana, 2,000 feet deep, where the ice dam was, it broke suddenly. 5 times the volume of Lake Erie spilled over eastern Washington. And anyway, I want to point out the shorelines. I actually have a whole book and DVD just on that subject alone. So lakes have shorelines. And this is another picture of the shorelines of Glacial Lake Missoula, north of Missoula. I don't think you can see them very well. I can't see them very well. Oh, there they are right there. Right there, yeah. But anyway, lots of shorelines. And there should be lake bottom sediments. See, when lakes fill up with sediments, a good part of them slough down to the bottom and fill up. The deepest part of the lakes get filled in. So the deepest part of these lakes, this is Lake Hopi right here, should have couple hundred feet of lake bottom sediments, but there aren't any. Same with canyon lakes, indicating those lakes didn't exist. And you couldn't scour out those sediments either because Lake Hopi is pretty big. It's probably at least 100 miles long, and it has a narrow entrance here. So if that broke through, it went through a slot canyon, very narrow, and so the currents would be going very fast through there, but when you got up in the main part of the lake, they'd be going very, very slow. So they couldn't scour out all the lake bottom sediments. So that's, I think, a fatal problem with the dam breach hypothesis. And here is that slot canyon coming out from Lake Hopi, or what would be considered Lake Hopi, in the Little Colorado River Valley. You can see it's a slot canyon. I'm not going to talk about that. That's the Bit-Ochi Formation is considered some lake bottom sediments, but they're found at the near the shoreline of where the lake was, and even above. Those that advocate the dam breach hypothesis try to say it faulted or it bowed up or something like that, but I don't think there's any evidence for that. So I don't think the Bit-Ochi Formation, besides it's mostly volcanic and fluvial with lots of currents, there are indications of some slow sediments, but I don't think they're a big deal. And anyway, the long tributary canyons. So here's kind of, I should have showed this picture right away. This is the Grand Canyon area. It starts about here, Lee's Ferry. That's where you can float it. I floated it twice. Here's the first plateau. There's several plateaus it has to go through before it leaves at the Grand Wash Cliffs. This is where you should find that huge delta. It's not there. Anyway, here's the Kaibab Plateau, and it slopes down to the south. And Grand Canyon's cut at intermediate altitude, 7,200 feet on the south rim, 8,200 feet on the north rim. The low point here is 6,400 feet, and the low point there is 5,700. So any lakes backed up here should have gone over those low points. They didn't. Now, those that advocate the dam breach hypothesis try to say it tilted this north-south tilting. And I think that there's no evidence for that. But anyway, that's where it breached. And then another interesting thing is it didn't go down the topographic slope like this. It kind of hugged the edge of the southwest edge of the East Kaibab Plateau. Like that. Why would it do that? That's another problem. There's several problems. And here's these long tributary canyons. Start up by Kanab, about 60 miles long, and they go all the way down to the level of the Grand Canyon. And here's the Havasu Canyon. It also goes down to the level of Grand Canyon. It's a mile deep right in here. Tributaries, when you have a drainage system, you have a main channel. And the tributaries, when it's flooded in the whole region, the tributaries drain into the main channel, and they will drain down to the level of the main channel. This is exactly what you'd expect if it's flooded from Kanab down over through here. 120 miles. That no dam breach hypothesis claims that. So that's a fatal problem, I consider. So here's another look at it. Havasu Canyon and Kanab Canyon. And here is Havasu Canyon coming into Grand Canyon. And it's a mile deep, slot canyon. So how would that form in a dam breach? I think it's impossible. Anyway, I think I might have missed some slides. Anyway, I believe it's a Grand Canyon's a water gap. There are thousands of water gaps across the earth. A water gap is a gorge through a mountain range or a plateau or any rock barrier where the river or some water flows from one side clear through to the other. There are thousands of them, and the Grand Canyon is just one. And I believe it formed by the late flood channelized erosion. And there's a water gap right there. This is Cody, where we're looking west towards Glacier Yellowstone Park, which you can't see. This is a water gap 2,500 feet thick, where the Shoshone River continues its eastward course and cuts through the Rattlesnake Mountains, where it could have easily gone around. This mountain range plunges and disappears 2 miles down there, and the Shoshone River could have easily gone around it. Of course, the rivers don't go up and down, so something else carved the gap, and the river just took advantage of it. And when you look on the other side, there's the water gap there, and here's the low area that the river could have gone through around. They built a dam in here, Buffalo Bill Reservoir. In fact, they had to actually put a dam in the south part here because it's so low. So that's the Shoshone water gap west of Cody, Wyoming. And so that's just one water gap out of many. Here's another, but I gotta move on here. Anyway, here's how I believe water caps form. The waters were draining off the continents. The continents were coming up out of the floodwaters as the ocean basins were sinking. And that was a tremendous amount of potential energy pushing the water up and water going down. So in places, the water's going 100 miles an hour. In some places, it's going perpendicular to a ridge. Maybe it's coming up. Waters are draining, ridges coming up, and there's low areas. And so it'll take advantage of the low areas and it'll erode those, but it'll erode them. The current has to speed up because the same amount of water has to go through a more narrow area. As it speeds up, erosion's approximately to the fourth power of the velocity. So you double the velocity, erosion goes up 16 times. So here's an example of a two forming, and it continues like this. And this one gave up for some reason, maybe because currents changed. Lots of reasons it could happen during the late flood channelized erosion. And so it's carved this all the way down, and so the rivers naturally take advantage of it. This one gave up too and it's left as a wind gap. Only wind's going through it, while the other water's going through it. So that's how water and wind gaps form late in the flood. And here's how I think, Dan, this is a more detailed how I think it formed. I think you had, by the way, I blued this to kind of give the impression it's underwater. And anyway, you had two main channels formed during channelized runoff because the Southern Rockies rose up and the water's heading for the Pacific Ocean. And one main channel would be coming northeast down Canyonlands area. Another would be coming up the low areas of the Little Colorado River. And these currents would converge at intermediate altitudes on the Kaibab Plateau. And that's where I think they formed a notch. And once that notch develops, it's, speeds up and erodes rapidly through there like this. So it erodes, gets the initial notch going. And then what about why the currents stayed at the same altitude on the southwest edge, the Kaibab Plateau? There's a little erosion here in the southeast too. I think this point right here, the southeast edge of the Kaibab Plateau, acted like a rock in a stream. And this current number one, I think, was a lot stronger. And so it hit the southeast edge like a rock in a stream, and it forms eddies and goes around the rocks, eroding around like this illustration right here, and leaves notches here. And that's why I think the Grand Canyon followed at the same contour level on the southwest edge of the Kaibab Plateau before it turned west. And there's many other things that we can say. Oh yeah, this is where I believe that the current number one was going faster. Number two, there's a lot of mountains and the hills that would kind of disrupt this and slow it up. And so this would have a straight shot down the Little Colorado River Valley, what is now the Little Colorado River Valley. And it would erode less on this side, but a lot more on this side. And anyway, I'm not going to, I think the convergence from the Kanab Canyon and Havasu turned the current to the west and so forth. I'm going to skip it from now on. And that's how I think Grand Canyon, there's one or two other problems, but I'm not going to spend any more time on it. I've already spent too much. Anyway, if you want to know more about it, even going into the strata on the walls of the Grand Canyon, I have a whole book on it you can get from the Creation Research Society, creationresearch.org, A Grand Origin for Grand Canyon, if you want to know a lot more about it. Anyway, I'm going to transition to the second topic I'm supposed to talk about. And that is about dinosaur tracks, eggs, and scavenge bone beds. Okay, I'm. By the way, I'm skipping a lot of this. This is an hour talk. Okay, maybe I will start here. Sorry to go through this so quick, but I want to get to your questions and answers.
Oh, no worries. No worries. I love the visuals and slides, Mike. I really appreciate it.
Okay, you're welcome. And so we have our challenges. This the secular scientists have a lot of challenges too when it comes to dinosaurs. They certainly don't have it made. And our main challenges, which is the only one I'm going to deal with, is how can dinosaur tracks, eggs, and scavenged bone beds, this was the main question that was brought up, scavenged bone beds, occur early in the flood? I mean, this was considered to be an unsolvable problem for flood geology. Well, a lot of problems seem unsolvable without looking into them very deep. But when you look into them deep, you discover, first of all, that a lot of times they're problems for secular scientists also, but you wouldn't know it, mainly because they usually add a secondary hypothesis to paper over the difficulty. You've got to get even beyond that secondary hypothesis and check that out. So they have their problems, and we have ours. And so I'm going to deal with only ours. And let's see. Anyway, these dinosaur tracks have been a real challenge to a lot of people. Here's a quote from the late Glenn Morton on his website. It's not on his website anymore. I guess he took all this stuff off. But anyway, features like these, termite nests, dinosaur tracks, cicada burrows, and channels are not easily explained by young Earth creationists. They don't show their followers this type of data, and they have not explained it. Well, that's 2004. I had an explanation in 1993. And anyway, you can form some of these other things by the same hypothesis. Termite nests, cicada burrows, and channels can be formed in this hypothesis, which I'm going to talking about. And a lot of people have really been challenged. Here's a guy who was getting his degree in geology out in the field, and he said this: by day, quarrying through the layers of rock, we started to come across footprints of terrestrial animals, says Godfrey. You can't imagine a global flood and animals finding ground to make footprints on. That, more than anything, any other experience in my life, really shook me to the core. So this is a major challenge. By the way, the Lord has led me to answer major challenges for the 45 years I've been doing research. Evolution, that's easy. I mean, there's so many major problems in evolution that other people are doing that. I don't focus in on that. But I focus in on the challenges that are difficult for us to explain. I forgot to tell you that after I find out that it's a challenge to secular scientists, half the time I discover a good possibility within the flood model. So that's where I find. But there's a lot of challenges left to go that I and others have not been able to explain. A lot of it we haven't done the research yet, because and some challenges no one's even touched, but a lot of them I have, and so I have a decent amount of answers for some of these, and this is one that I do. Anyway, here's a typical dinosaur track, three-toed theropod carnivorous dinosaur track from northeast Wyoming, and believe it or not, that is a large duckbill dinosaur track found on the top of a coal mine in Utah. Yes, indeed, you find dinosaur tracks on the tops of coal mines, Utah, Colorado, Wyoming, Queensland, and the United Kingdom, at least, probably more. This can be explained by this model that I'm going to bring up: dinosaur tracks in coal, on top of coal. Anyway, here's a challenge: dinosaur tracks. There are millions of them now, and they're finding new ones all the time. In fact, I was just up here in Denali National Park in south central Alaska, where they got oodles of dinosaur tracks in that park. And I saw some, got new pictures, and so anyway, here's one on Spitsbergen, island of Spitsbergen. Whoa. Anyway, we have to explain all that. Millions of dinosaur tracks. And by the way, these are live animals that laid eggs, made tracks, and scavenged bones. So they have to be early in the flood, and the sediments are accumulating. And here's a picture of eggs from Mongolia. And here's eggs, generally found in these areas you see here, and they find eggs. I don't hear too much about finding new eggs with time. By the way, these slides are old, from the late 1990s, so they have more in more places. But this is a great accumulation of eggs where I live and down south, Wyoming and Colorado, and China, Mongolia, and so forth. Anyway, the question was, a lot of bone beds indicate scavenging. And here is a bone with teeth marks from a carnivorous dinosaur. So yes, we do see these signs in the bone beds. So yes, and here's from the Museum of the Rockies, we have teeth marks on this. I think this is a frill of a triceratops. Teeth marks. And here is a tooth of a T-Rex found in a bone bed in northeast Wyoming. And you know, when you only find, see, they lose their teeth when they chomp on a bone, it a lot of times breaks off. So when you only find the teeth in the bone bed, and by the way, some of these bone beds have thousands of individual dinosaurs all in a small area. But when you find the teeth of carnivorous dinosaurs only and not their skeletons, you know it was scavenged. And so they were scavenged during the flood. So man, these seem like serious problems. I thought so, but when I looked at it closely, I discovered some interesting things. Well, I'm not going to go into this. Okay, I discovered unusual features of bone beds and tracks and eggs. And here's a list of the unusual features. First of all, there's numerous dinosaur graveyards, some of which are huge, like in Montana here, north of here, there's a bone bed of 10,000 duck-billed dinosaurs, all the same species. And I might add that they're all mixed up. They're totally disarticulated, and it looks like they've died one area and they've been re-eroded and redeposited, because sometimes you find the left leg bones of two dinosaurs together, and it should be a left and a right if they died there. But so it indicates that they died in a massive graveyard. Then that graveyard got re-eroded and redeposited. That seems to be common in a lot of graveyards, but some of these, like 10,000, China and Alberta have a lot of huge dinosaur graveyards, and commonly described as being buried in a flood. I mean, the way I have some quotes, which I think I'll have to skip. Often the bones are jumbled together, like I was saying. The bones are little weathered. Many bones contain just one type of dinosaur. Now, how would that happen? You know, when we have catastrophes today, it'll bury a lot of different animals, say a huge rock slide or a volcanic eruption. When it sends sediments down the mountain, it'll cover a lot. And so a lot of different animals, and it's certainly not the same species of one animal, just a variety. But many of these bone beds contain just one type of dinosaur, or the vast majority of them are one type. That is unusual. That speaks of an unusual catastrophe. Also, the bones of babies and young juveniles are rare. They're found, but they're rare. Now, when you find that you find a catastrophe, a lot of times you'll find just as many young and baby bones as you will adults and older juveniles. So that's rare. Could it be that the babies and young juveniles could not escape the encroaching floodwaters while the older ones were able to flee for a while? I think that's a good possibility. And here's a jumble of, in New Mexico, a Coliphus graveyard, about 1,000 carnivorous dinosaurs all mixed together. I mean, that's flood. That's Genesis flood, not some local little flood. And a lot of times you find these bones in mud, all broken up. In fact, these white areas here are pieces of bone, indicating catastrophic smashing, breaking up, and huge catastrophes for these dinosaurs, and ending up in this mudstone here. And here's some, I'll just quote this one. Piled in like logs in a jam. That's how he described bones. So I have a lot of quotes. Unusual features of tracks. Tracks of likely poor swimmers are rare, like Triceratops tracks are rare. Ankylosaurus, you wouldn't think they would swim very good. And I think they're finding more of those now. Tracks of Stegosaurus, which you wouldn't imagine swims very well with those heavy plates and the spike tail. They're fairly rare. So you find, why are tracks of likely poor swimmers rare? You find a lot of duckbill dinosaur tracks and a lot of theropod, three-toed dinosaur tracks. You'd imagine with their big, thick body, small arms for the theropods, that, man, they can probably float pretty good. So, and that's how the majority of tracks are from them. And practically all tracks, again, are from adults and juveniles, older juveniles, similar to the bones. And interesting, the tracks are practically always straight. I live in Montana, and I'm a elk hunter. And I like to hunt elk in the snow. And when you track them, when they're not spooked, they go all over the place, take sharp corners. But when you spook them, then they run in a straight line or a gently curved line. And the tracks are practically always, if not always, on a single flat bedding plane. I mean, they don't have other bedding planes where they climb up. There's no hills. It's always a single flat bedding planes in sedimentary rocks. And then you have multiple areas where you have multiple track layers. A track layer here, and then maybe 150 feet of sediments, another track layer. And at least in northeast Wyoming, the tracks were almost identical on the two layers, but yet because there was that much sediment in between, they gave it 3 million years. What's the odds of the same types of dinosaurs coming to the same area 3 million years apart? So on all these unusual features, here's a straight track in northeast Wyoming, a theropod track right in here. And here's the plot of that there. They're generally straight or gently curved. Unusual egg features. There's very few actual nests. That's a bowl with vegetation on it, either or. You don't see hardly any bowl structures, maybe about less than half dozen. And you don't find hardly any evidence of any vegetation like from pollen. So there's very few actual nest structures, but they claim nests. Mainly when they see a bunch of eggs on a flat bedding plane, they call that a nest. But it's not a nest. You see, you got to watch out for some of these descriptions. Got to dig deep. Their eggs are laid on flat bedding planes. Little or no vegetation associated with the eggs. The eggs, and here's the upshot of this. The dinosaur eggs are quite porous, meaning they'll dry out sitting on a flat bedding plane. So it indicates that the dinosaurs did not have time to dig a nest or find vegetation to cover it, but had to lay it quick on a flat bedding plane once they found a flat bedding plane. Well, how do they find flat bedding planes? Well, that gets into what's called the beds hypothesis. Okay, that's one actual nest structure on Egg Mountain, Montana. Anyway, I believe the beds hypothesis can explain it. Beds stands for briefly exposed diluvial sediments. Diluvial is an old name for the flood. So they're briefly exposed, freshly laid sediments. And why? Because sea level or the flood level, as it's rising during the early part of the flood, it's oscillating as it rises. You see, by 5 different mechanisms. And so, and there always seem to be in areas of rapid sedimentation. So, and then you have evidence of a lot of sediment piled on top that was eroded. So, so as you get a local drop, when the floodwater is shallow, it can expose the freshly laid flood sediments. And then a rise will cover it up because you got to preserve all this stuff quickly before it disappears or decays. So that's the bed hypothesis. So here's a block diagram. Think of these blocks as maybe an area 100 miles in both directions. A big area, but this is just narrowing it down so I can get it on a piece of paper. Anyway, here's the top of the sediments at T1, and it's rapid sedimentation. T2, it's up here. T3, it's up close to the top of the floodwaters. Then you have a local drop, and that exposes the bedding plane. And then dinosaurs floating in the water, swimming, or on higher ground nearby, if there is any, come onto that, lay eggs, scavenge dead dinosaurs, and make tracks. And then you have a local rise that'll cover them up and preserve them. And it can happen more than once, to have multiple layers in an area. Also, for a log mat, there's probably billions of logs floating on the floodwaters. So a local fall would beach these log mats, you see. And then if it rises quickly enough and puts sand over the top of it quickly enough, it'll pin the plants down. And as you pile up sediments, it compresses it, forming coal. And dinosaurs could have walked on that plant matter before it was pinned by the next rise to form the dinosaur tracks in coal, explaining coal and dinosaur tracks. And here's the 5 mechanisms. I'm not going to go into, there's probably more, there might even be more mechanisms, but lunar tides, of course, are pretty obvious. Twice a day going up and down. Some of these, like tectonic uplifts in the area, could last maybe a couple of weeks being exposed. I mean, so there's different spatial and temporal scales in all of this. And here's a little quickie, a block diagram again. Think of freshly laid sediments, do a drop, and they lay eggs, make tracks, and there's dead dinosaurs around. They get beached. And then a local rise. It's muddy water, by the way, so it's going to cover it all up. And this is just one possibility. In this case, it didn't drive those dinosaurs off. So that another drop, they can do it again. In other cases, it would rise and you could put 150, 200, 300 feet of sediment and then fall again. So you had a lot of variability and a lot of possibilities to explain features on multiple tracks. And by the way, you can explain dissociated features. I think I would get into this. Yeah, you can actually have true mud cracks. It only takes maybe less than 24 hours to form a mud crack. You can have raindrop imprints, which you do have. Bird tracks, there's lots of bird tracks with the dinosaur tracks. Coprolites, paleosols, burrows, social insect nests. All these can be explained with the beds model, which a lot of these are considered big problems especially for the early flood. And these are mud cracks. I think I'm going to end it there and go to the questions. This is a picture of mud cracks in a dinosaur quarry in Utah. Anyway, I think it's time to transition to questions and answers because there's only an hour left and I have company at 6 p.m. So I only have an hour, unfortunately.
I appreciate that, Mike. I really appreciate how informative your answers are. And as I said before, I always love the slides. So we're getting a lot of great feedback in the chat. I appreciate that. I also want to let people know that a lot of these questions, Mike, as you've pointed out, can oftentimes require an hour lecture and presentation. Yes. And we've had you on 3 times before for just that. We've had you on for 3 presentations in the past. So definitely check that out. And we've got so many questions here, about 100. So I guess we'll just start right at the top. So Mike, we're going to need you here for 10 hours. You might want to cancel that party. No, I'm just kidding.
I want to stop sharing screen. Should I do that?
Yeah, I can do that from my end. So I've removed.
Okay, because I have 2 other PowerPoints up that maybe I can answer a question real quick by some diagrams. But anyway, okay, fire the questions away. I can't see anybody out there. I can't see the questions either.
Okay, I will. We'll read them to you as I've saved them all. George, you want to just start right at the top then? I mean, I know we've got a lot of questions here relevant to the presentation that Mike just gave, but let's just start right at the top. First question that came in was from Redefine Living. So question for Mike: how would you respond to a critic that suggests the deep time assumptions of the geological column are somehow necessary for oil exploration?
Okay. My first thought on that is that some oil geologists and paleontologists might think that. But I've talked to other creation geologists that have worked in the oil patch that tell me that that's not necessarily true. Oil, you find them in geological structures, traps. You look for traps, but it wouldn't matter what the age of the rock is. Usually you want to go down to a certain depth to tap the structure that was trapped to get into there. So a lot of it would have absolutely nothing to do with flood geology or the geological column. It's just practical ways to look in the rocks and look for the signs, so forth, for oil. So I'd say it shouldn't make any difference at all.
I appreciate that, Mike.
Yeah.
George, did you want to add anything, brother? Or did you want to go right to the next question? It's up to you.
Well, lots of experiments have been done on formation of oil, and you don't really need lots of time. You just need the right conditions,
Yes,
temperature and pressure. So, no, that's not a problem. Mike, question here asking for an explanation. It's from the Science Ultimatum with Jason Tom. I think it's Tom. It says, please explain, under a global flood model, how desert formations can interlace with formations that are attributed to water deposition / marine sedimentation.
Yes, the desert sandstones. Yes, there's claims of a lot of desert sandstones around, especially in the western United States where I live. John Whitmore, Ray Strom, and others have actually looked at the classic sandstone that's supposed to be windblown, the Coconino sandstone. And, lots of papers saying it's windblown, but when they looked at it, they discovered, first of all, the angle of repose wasn't really steep as you expect in sand dunes. Secondly, you'll find mica and feldspar. These are easily weathered grains that would weather out in a desert, and but can be deposited rapidly by flood deposition. I think it's the big cross beds in sandstone that really made them think that they had to be from desert dunes. But since then, they've discovered in a lot of places in the bottom of the ocean, fast currents can create large sand dunes with big cross beds. So that no longer should be a big deal to them. But the indications are that the Coconino is a water lade. Besides that, it transitions into the Glorieta sandstone in New Mexico that is marine. So, and the largest sandstone in the world is probably the Navajo sandstone. And in the Navajo sandstone, you have a lot of dinosaur tracks of the three-toed carnivorous dinosaurs. And you have some vegetation, vertical trees, and lots of indications that there was water laid, especially the dinosaur tracks. What are three-toed dinosaurs going to eat in a desert? So I believe that these are not really desert sandstones, but they have mistakenly said they're dinosaur sandstones. And like I said, Whitmore and others have done a lot of research, tremendous amount of research on these so-called desert sands. And they discovered, no, they're water laid. The evidence is that they're water laid when you look at them closer.
Yeah, Donnie, can you share my screen? I just want to add something to what Mike actually just said that sort of supports his argument.
Sure. Yeah. You're shared. You're good.
Can you see that image of the recumbent fold in the Coconino sandstone?
Oh yeah. Yeah.
Mhm.
Okay, well, Mike, feel free to jump in anytime, but
You
I
do.
don't believe you. I don't believe you can get recumbent folds in a desert formation. Wind doesn't do that.
Yeah, right. Exactly.
And the other one is the tsunami. There's the tsunami off Japan that actually showed how quickly sand waves can be made during a flood underwater.
Yes.
I read the other night in the Nationals, what is it, NCSE? I call it the National Centre for Science Miseducation.
I know. Yeah.
They still have this example of desert sand dunes can't be created underwater. I mean, come on, guys, update your material. And further to that too, Mike, we covered a couple of weeks back where we showed, I think it was the Mount Zion formation, where you got sandstones there that are interlaced with limestone. Limestone only happens in a water environment, not in a wind environment.
Yes.
Yeah.
Yeah, we have lots of evidence.
Yeah, I'd like to sort of add that, which is visual evidence people can see, and they can't really refute things like that.
Yeah, and that brings up a point. Critics. A lot of times critics have not read our material. And we got 60 years of technical research published in 3 creation journals. They hardly look at that or even look at a lot of our books. And they come up with a huge amount of straw man arguments that are just easy to slash. And they accuse us of saying things which we don't believe. And so it's poor scholarship.
Yeah.
I think critics got to do a lot better job, first of all, finding out what we say before they try to shoot it down. And that's the first of many problems with what the critics have come out with, I've discovered.
Agreed.
Especially, Mike, when observational evidence refutes what they're actually claiming.
Yes. Yeah.
All right. Well, let's get right to the next question. Great point, gentlemen. And I want to say I agree as well. I've discovered that only doing this for a few years, I've found that the critics put forth these arguments that are answered in many of our technical papers, articles, books. I mean, which is why I've linked your website and also the section of articles on creation.com for people to check out, because I've spent hours reading those. So next question here comes in from Germania. So question for Michael. The Grand Canyon does not have fossilized grains, in brackets he puts from pollen, but it does have spores from moss, fungi, and others. Wouldn't this have been mixed up in a worldwide flood?
Okay, let me see if I understand the question. He's saying that the sedimentary rocks have pollen and spores. Is that what he's saying?
Yeah, he says apparently it doesn't have fossilized grains from pollen.
Oh, doesn't?
It does have spores from moss, fungi, and others.
Okay.
And then he asks, wouldn't this have all been mixed up, I guess, in a worldwide flood?
The worldwide flood was more complicated. You buried environments. And so you don't necessarily mix the whole biosphere up, from the deep bottom creatures to creatures that lived in the higher terrain. You just don't mix them up all at once. So environments were deposited, and so you wouldn't have a big mix-up. And you can have pollen grains and spores, mixed in with even sandstone. There's not a lot of fossils in sandstone, but there are some, and you can have that. Well, I don't quite understand the problem. Maybe maybe I'm misunderstanding it, or maybe you can address that better than me.
Yeah, well, if he's, I've got so many questions here. Maybe if he's in the chat, he can almost reiterate it at a later point in a way that might be more understandable. So here's the next question that is kind of similar in terms of what we find in the burial during the flood, and it's from Colin Parkinson. And he says, and this is referring to some of the visuals you had in the presentation. He says, why don't those dinosaur boneyards also contain mammal and human bones? Surely the bodies would be jumbled together in the one worldwide flood. So I guess it's kind of similar to the other question, is why don't we find certain
similar but different? Like I said, I believe ecosystems were deposited. And by the way, there are mammals with those dinosaurs. You don't hear about them much because they don't want to focus in on them. And some of them are kind of modern looking mammals. Not too many, but a lot of them are little rat things. Starts with a T. I can't remember the name of it, but they're commonly found fossilized with dinosaurs. But like I said, I believe it was by ecological zones, not only vertical between the bottom of the ocean to the high hills, but also I think there's a horizontal zonation, which not too many creationists have thought of, but I have, and I think that can explain some of these things. So in general, you don't find a lot of the modern type mammals or their kinds with dinosaurs. Sometimes you do, but often you don't. It's because you find a lot of bird tracks with dinosaurs, and birds could have survived on the log mass for a while and flew onto those briefly exposed alluvial sediments, making tracks. So that's pretty easy to explain. Just different ecological zones, vertically and horizontally, were deposited in layers over fairly good areas. So I think that's what the flood did, and so you wouldn't have a big jumble up of all kinds of creatures.
Right. Great point. Great response. Yeah, go ahead, George.
Yeah, Mike, if I could add something to the previous question about the pollen and the spores. I'm not sure if you're aware. You probably are aware of the Mount Roraima pollen in South America. Apparently, it was found in I think it was 1.7 or 1.8 billion year old rock strata.
Yeah,
with hundreds of feet of overburden, which is get a load of this, which is long before multicellular organisms evolved, supposedly 380 million years ago.
Mm-hmm.
That's in a paper by Stainforth RM, and it's titled "Occurrence of Pollen and Spores in the Roraima Formation of Venezuela and British Guiana."
Mm-hmm.
Now there are rescue devices for this, and I laughed when I read this. It says one of the rescue devices. The resulting groundwater would have deposited the pollen and spores in largely, get a load, unnoticed microscopic openings in the subsurface hornfells. That's fantastic, isn't it? An unnoticed.
So yeah, I vaguely recall that paper, but I know a fair amount about the Roraima formation. It is about 1.7 billion years supposedly. Yeah. But the interesting thing about it, it's almost a pure sand, quartz sand cemented together, called a quartz arenite, which is very unusual. And they might be forming in tropical areas but maybe not. There's a lot of questions on that. I'm doing research slowly on that. But anyway, this formation is probably about 1,000 meters thick, and it's sand, almost pure sandstone, cemented to sandstone. And there's evidence that you had probably 3,000 meters of sediment above it that all got eroded, leaving these sandstones as big mesas in southeast Venezuela and Guyana. So tremendous erosion during the runoff of the floodwaters. So yeah, the Roraima Formation is very, very interesting.
And the other thing too, Mike, is wouldn't seeds, being quite small, float?
Oh yeah,
They'd be on the surface.
Pollen and spores would be in the floodwaters and get mixed with the sediments.
Yeah.
So I don't see a problem with the flood depositing these.
No. Yeah.
Well, great information, brothers. So, George, I'll get this next question, and then since we have so many, I'll let you choose a couple that you find might be relevant to the discussion. So this question, Mike, has to do with an article you wrote for CMI. So you wrote an article for CMI focusing on well-watered deserts and how the flood solves another ice age mystery. And I've read this as well, and I thought it was fascinating. Can you expand on this?
Well, we find that desert areas, including the Sahara Desert, have lots of evidence that they were well-watered, big lakes, big rivers. Like the Sahara Desert has fossils of hippos, and they got tens of thousands of man's rock art in the Sahara, and so lots of evidence that that during the Ice Age, during the Ice Age, and for the Sahara a little after the Ice Age, that they were wet. The reason they're wet is because during the Ice Age, the ocean water was very warm, especially the mid and high latitudes, and evaporation is proportional, among other things. It's also proportional to wind speed and other things, but it's proportional especially to the sea surface temperature. And at the end of the flood, early part of the flood, midway in the flood, the sea surface temperatures would be much warmer, mainly at mid and high latitudes. So the net effect of this is huge evaporation from the ocean. And the evaporation is 3/4 the cooling of the ocean. That's why we can time the Ice Age, the cooling of the ocean. And so all this water not only will produce a rapid Ice Age, but places that are not glaciated will have a lot more precipitation. And so areas that are now deserty areas, like around 30 to 40 degrees north and south latitudes, were wet. And we have the evidence, abundant evidence for this in many different features. And so this can be explained by this type of Ice Age. The secular Ice Age is very cold and dry, so it's very difficult for them to explain these big lakes. I showed you a picture of the pluvial lakes in the southwest United States, which is a semi-arid area. Lots of lakes, and even ones that are there that I didn't show you. Big shorelines. Now, Great Salt Lake is 12 feet deep now. During the Ice Age, the lake that was there was about 10 times the size of Great Salt Lake and 800 to 1,000 feet deep. Huge lake there. And so this could all be explained by low areas being, first of all, ponded after the floodwaters ran off. You'd have water ponded in areas that are basins that don't have an outlet, like the Dead Sea area, for instance, would have a big lake. And so this could be explained by the flood and by the Ice Age. And as far as the Sahara Desert, the indications are that a lot of the wet areas, the end of the Ice Age and after, and I think there's an explanation for that in that that will be published in the next Journal of Creation this fall that's online. So those that get a subscription will see the solution to that issue. but in 30 seconds or less, it's the rain belt in Central Africa would be pushed further north because the ice age didn't peak in Antarctica until about 1,000 years. Well, it peaked at 500 years in the northern hemisphere. So that rain belt would have been pushed by the winter hemisphere further north. And so you'd have more precip in the Sahel and the Sahara Desert. The Sahel is the area between the dry Sahara Desert and the area in Central Africa that's a rainforest area of heavy precipitation, 1 to 3 meters a year. So it can all be explained, but yet the secular ideas of the Ice Age have severe problems explaining what's called wet deserts.
Yeah, thanks for that, Mike. The next question, if you don't mind, I'll answer it and you can add to it because it's a question from Colin Parkinson. And I keep hearing this from a lot of evolutionists. So I'm sorry, Colin, if you're not an evolution, I apologize. But he says, why don't those dinosaur boneyards also contain mammal and human bones? Surely the bodies would have been jumbled together in one worldwide flood, right? Well, Colin, I'm not sure if you're aware of the Ashley phosphate beds, but that's exactly what they found. They found human bones with mammals and dinosaur bones. Not much is actually said in evolutionary literature about the Ashley phosphate beds, but I can assure you if you do some research, there's a book written by Professor Holmes, a paleontologist, who has written extensively on it. There are also geologic studies that were done of the actual beds themselves. And the interesting part was that got me when I first actually researched this thing is they found all these bones, these fossilized bones in about an 18-inch layer. I think it was overburdened by about 20 feet of sediment. So that's an amazing discovery, yet you will never hear that coming from an evolutionist. Over to you, Mike.
Where is this phosphate bed? I hadn't heard of it.
Oh, it's in America. In what's the place? I can tell you. So not even creationists know about it.
Is it in the southeast part of the U.S., Georgia, Florida, and then maybe South Carolina near the coast? Is it that phosphate bed?
South Carolina, yes.
Okay. Well, I don't know a lot about it. All right. There's a lot to learn.
I'll send you heaps of it, Mike, because I've done a lot of research on that. And yeah.
Well, like you said, Mike, there's just so much to learn. It'd be nice if we had 500 years to study this like our early biblical patriarchs. So the next question comes in, and I appreciate that input, George, on that question. There's a couple of good questions here. I'll start with this one because I remember reading an article from you on this on CMI. So the question is, are fossil stromatolites a problem for a global flood?
Oh, yeah. Since I read about or try to keep up with 50 Earth Science journals, I had more time, there's about 50 more. I read about all the problems, so I'm well aware of the problems, and stromatolites is a problem, and it's debated within creation circles right now. And I'll tell you what I think. I've written about them. Stromatolite, you find them today, kind of in mounds, maybe a meter tall, in southeast Australia. Shark Bay is called. You have them there, and they usually isolated, or sometimes they're next to, there's two or a few more hooked together. Generally, they're kind of isolated vertical mounds where they're formed by bacteria, algae, and I think diatoms, but I think diatoms is a type of algae. A lot of different organisms, and they bind the sediments together, and then they cement them and form these kind of this upside down dish structures, one on top of another. They build up to a meter or so tall. You also find them in the Bahamas. And then there's other things that are similar to them you find in some lakes. They give them a different name sometimes than stromatolites, but we can call them stromatolites for sake of discussion. So there's a lot of Precambrian stromatolites. And in fact, I plan to look at some this September here in the what's called the Mesoproterozoic belt supergroup. It's a series of formations, 20 kilometers thick, I might add. It's very interesting formation I'm going to write up on, but there's stromatolites in a few areas there. I've seen them before. I'm going to look at them closer again. So they're abundant in the Precambrian. And they're less so in the Phanerozoic, but they are in the Phanerozoic. In fact, there was a recent article in the Answers Research Journal that found them in what's called the early Paleozoic stromatolites in Utah of the United States. But they're all through the geological column. But I've discovered that they're a lot of times they're different than the ones we see today. First of all, they are sometimes mounded, but they're usually connected for a long distance, connected together, and they're not like that today. And stromatolites are practically always found in limestone. And stromatolites today in the Bahamas are in limestone, but in Southeast Australia, the sediments they bind are not necessarily all limestone, and they're coarse grain particles in Southeast Australia, Shark Bay. Well, in the geological record, they're practically all thin limestone laminae, thin bands. So I think we have problems explaining that they're biological, not only in the Precambrian, but in the Phanerozoic, which practically all flood geologists believe were laid down in the flood. So I don't think they'd be living, because it takes a lot of time to find these sediments and form a meter-high mound. You mostly don't find those sorts of structures in the rock record. So there's also you find hardly any microfossils associated with them. You do find a few, they're rare, but you find a lot of microfossils in Precambrian strata. And so by chance, you're going to have some in stromatolites. But I mean, if these are biological structures, you should see a lot more evidence of microfossils, which are well preserved in the Precambrian. And so I had other features. I published it in the Creation Research Society Quarterly back in 2008. But I am thinking that I need to publish something coming up. Unfortunately, I have so many things to publish because I got newer information. Some of the secular scientists think that a lot of these can be non-biological. And so they even have mechanisms for the possibility that they're non-biological. And so I'll be looking at that. So the upshot, I don't think they're biological structures, and they're just laminae that are distorted in various ways for some reason. And so that's my feeling on it. But other creation geologists would disagree with me. See, we're sophisticated enough to have multiple ideas, and
Right.
that's not bad to have multiple ideas when we don't have enough data. It's called the principle of multiple working hypotheses. It was actually developed by T.C. Chamberlain, a geologist in the late 1800s, to try to explain a lot of geology formations. We need to have a lot of ideas out there, and that's where we are in flood geology. We're a lot newer than the secular geologists. And so we need to have multiple ideas. It's not bad. So we do research, and with time we either modify the idea, reject it, or one will come out shining and we'll accept it. So that's kind of the way research should go, and it generally does go in creation science.
Amen. Amen. I love that response. Very important response. And it's incredibly important to understand that, yes, having multiple working hypotheses is important, especially in light of new data that's always coming about, like you pointed out, Mike, which means, we're always, I guess, going to the drawing board and kind of working towards the best model, as you pointed out.
Yes.
And
yeah, if you don't have that, you end up with egg on your face.
Yeah.
One casing point is the junk DNA. I love that one.
Oh, junk DNA. Yes, you could talk about that.
Yeah, that's been overturned. I also want to point out to everybody in the chat, we got a great chat. I have been posting your articles that are relevant to these questions. So I just posted in the chat your article. I did find it. Are all fossil stromatolites biological? So I posted that, as well as the previous question had to do with well-watered desert. So I posted that as well for people to look at. So that being said, George, I'll give you the opportunity to pick the next question out of this massive list of questions.
Okay, well, this is one of my questions, not necessarily from the audience, but I wrote it down yesterday. It is, Mike, it is claimed that the Grand Canyon Supai and Hermit shales found today beneath the Coconino sandstones look exactly like river deltas that formed above sea level. Fossil prints and mud cracks are found today, as well as iron oxides that form in the open air, showing that these shales formed above sea level. How do you answer that claim?
First of all, the cracks. Whitmore did a study published in the Creation Research Society Quarterly that those are not mud cracks in the Hermit Shale, but actually sandstone dikes where you got sand, or you can have other things going up that cut against the strata, and sometimes it forms a polygonal pattern at the top. I've also seen this with rhythmites in the lake from drainage of the Lake Missoula flood in southeast Washington. So that would answer that. And what were some of the others? That's many questions into one. It sounds like.
Oh, the footprints.
Footprints. What footprints?
Fossil prints. Fossil prints and mud cracks are found today, as well as iron oxides that form in the open air.
By the way, speaking of mud cracks, there's a lot of those claimed for the belt supergroup, but a lot of researchers claim that they're not really true mud cracks. They're there's several types of cracking that can occur, especially due to hot and cold water, changes in pH. They call them syneresis cracks, or as one type, and diastasis cracks are another. They form underwater, and so they might not be true mud cracks. And the ones in the Hermit Shale, I believe, are actually sandstone are a result of diking. Under pressure, you form. You send sediment perpendicular to the beds up, and then and so it's not really a true mud crack. I think that's, unless you know something else that I don't know. As far as the tracks, I had not heard of any tracks in the Hermit or Supai. I can't recall right now, but there's tracks in the Coconino sandstone. They seem to be going up cross beds commonly, and so there are what looks like amphibian tracks in the Coconino, but maybe they're down in the Hermit and the Supai also, but I can't recall them right now. But that doesn't mean they're not there. It's just that research is 2 steps forward and 1 back, so I forget a lot. And by the way, the older I get, the more I'm forgetting. So,
welcome to the club.
And then you mentioned something about iron. What's the deal with the iron?
Well, this question came from the NCSC website. It says, as well as iron oxides that form in the open air.
What?
It's saying it's unusual to find it underwater. I mean, why? I'm thinking, why would that be?
I think they should check that. You probably have heard me talk about the quartzite rocks, which are metamorphic sandstones that are found mainly in western Montana, northern and central Idaho, and you can trace them 800 miles east-northeast clear into central Saskatchewan and southwest Manitoba, and other places all around the Western Rockies. And in fact, that's part of one of my presentations. Most often when I see these rocks, they have an iron staining on it, an iron oxide patina. So these things are spread in the floodwater, underwater, and they're coated by iron oxide. In fact, I'll show you one. Everyone see that?
Yes.
Yep.
That's quartzite, and it's heavy. And it's coated by iron oxide, and it's very common in all these quartzite locations to find this iron oxide. And this was all done underwater. And by the way, you see those percussion marks on there? Semicircular cracks, like right there.
Mm-hmm.
This one has hundreds of them on it.
Wow.
My favorite pet rock.
That's awesome.
And so I think it was a high iron environment. In fact, we have banded iron formations in the Precambrian, which are alternating iron and chert. Very unique. Haven't been explained by either secular or creation scientists. And yet they will say that iron oxide, sometimes it's bright orange. You find it in Southeast Australia is a good place to find it. It's kind of orange and light colored alternation laminae or thin beds, and that iron formed underwater, iron oxide. So I never heard of anybody making that claim.
Yeah, Mike, can I just add something? Like this comes from a NASA website. Hematite, which is a common iron oxide, or
Yes.
Commonly known as rust by everyone,
Yes.
is found on the lunar surface, and there's no air on the moon. So,
there's evidence of water in some places on the moon.
yeah, that's right. But the thing, one of their explanations is they're saying the cosmic winds have blown oxygen off Earth onto the moon's surface to cause this iron oxide. I don't know whether that's possible or not, but that's their explanation.
That's kind of far-fetched, but it is possible. But well, yeah. It could have formed in the air. It could have formed in the little bit of water they're now finding on the moon, which is rather interesting. I have to write a little article on that eventually. It's just one of the many things I have to write that I can't do at the moment. I have to wait on that one.
One of the unlimited projects.
I got a lot right now. A lot of them are big and long, so I'm preparing some talks for the International Conference on Creationism, so I'm focusing in on that at the moment, and so I got to do some more research for that. So that's kind of what I'm doing right now.
And do you have articles and papers? The last time we spoke with you, pertaining to the flood boundary.
Yes.
Out? Okay, I'm looking forward to reading those. And we've had you speak on that extensively in previous shows. I find that to be a very interesting topic for sure.
Yeah, I got 33 criterion, and Tim Clary has a few more that indicate the post-flood boundaries in late Cenozoic, defined as the Miocene, Pliocene, or the Pleistocene. We can't use a particular spot in the geological column, because all this is rather arbitrary. They're dates, so we can't say this is its point at the Pliocene, Pleistocene. No,
Right.
every place has to be examined on its own merits, but it's practically all late Cenozoic. For instance, coal, when you got to compress plants by overburden. In some cases, it's thousands of meters of overburden to form that coal, get enough heat, and then it gets eroded off if it's at the surface. And that can't be post-flood at all, because you can't get all the vegetation together in a spot and compress it with a big overburden, then erode it off. Thousands of meters. And by the way, you find coal clear up in the Miocene in a number of areas in the world. So obviously the flood post-flood boundary, if you want that, is well above the coal layer, probably up in the late Pliocene to the early Pleistocene in the geological column. So that's just one of many. There's lots of features like that. And I have even a whole book on my website on that topic, as well as that 6-part article from the Journal of Creation fleshing out those ideas.
Yeah, I've actually got those in front of me on the CMI website. So those are must reads for everybody in the audience. So much good information there, Mike. So this question now comes in from Germania. I appreciate the question. Question for Michael. He says, how do you get around trees that have been around longer than the alleged Noah's flood?
What trees? I think there's a lot of big questions on that. There's some claims that, well, first of all, tree ring dating, they use dead trees mostly and match little portions, maybe 300 years from a dead tree with another part of another tree, and they match those rings, and they stretch it out to 10 to 11, in some cases 12,000 years in their time scale. Bristlecone pine in Europe, they use pines and oaks, and they claim the oldest living tree is probably older than the flood. But I think that a lot of those rings are multiple rings, and that's the only place I know of the White Mountains for the bristlecone pine where they claim there's a tree older than the flood. Now, they've dated some trees with rings, maybe 20,000 years, but I don't think it has enough rings to be over 4,500 years old. And the reason I think there's multiple rings for the bristlecone pine is because I haven't published this again. The idea I have is that during the Ice Age, you had heavy precipitation, mild winters, cool summers. And so in the area of the White Mountains, which are in the rain shadow of the Sierra Mountains, which are 13 to 14,000 feet, the White Mountains to the east are only 10 to 11,000. I've been there before, by the way. So it's kind of in the rain shadow of the Sierras. And so if you have little temperature contrast between the seasons, but you probably had big wet and dry cycles, probably not too dry, especially at the beginning, but you had variable wet cycles. And probably every wet cycle, especially with heavy precipitation, in the White Mountains could produce a ring just from the numerous wet cycles in 1 year without any change in winter temperatures, which would be mild, and summers would be cool. So I think you can form multiple rings that way. But anyway, that's my idea of how to form those. If they're truly, well, they have enough rings greater than the flood at 4,500 years ago, so I think that multiple rings can explain any of those. And so I don't know of any others. If maybe the person who asked the question would give me a specific information.
No, I think that was thorough. I think that was a great response.
Mike,
go ahead.
can I just add something to that? when I go up to the mountains, Mike, there's quite a few pine forest plantations. And if you ever walk through a pine plantation, apart from the fact that you really breathe air that's rich in oxygen and you get a real high out of it, but you'll notice these pine plantations were all planted at the same time. But you'll notice slight variations in the diameters of the trees.
Oh, yeah.
Which suggests if they're planted at the same time in the same ground, some are growing faster than others. Either the ring is thicker or they have multiple rings. Now, I've done my own research on this. I've planted trees in my own block here, silver birch trees. There are 4 silver birches, and they're all different diameters, and they're all planted at the same time in the same material. The same thing has happened in my street where they've planted pine oaks in the nature strips. The same observation, different diameters, planted the same time in the same material.
Oh, yeah, and you can get different widths of the rings at various places around the tree, too. So
Correct,
there's a lot of variability.
Yeah.
Correct. Well, here's a question that just came in, George. Maybe I should get it here in the last 10 minutes that we have. I put it up on screen, but I'll read it out for you, Mike. Question from Andrew Cumming. Looks like it has to do with something we were discussing in a previous question. So he says, can you please ask Mike Oard why he thinks the Great Oxygenation Event does not explain banded iron formations?
The Great Oxygen Event is a secular idea, and they believe there was no oxygen in the atmosphere from about 4 billion years when things settled down from the bombardment until about 2.4 billion years. Then you had a rise in oxygen, not up to today's level. Then you had another one later on in the Precambrian, the late Proterozoic. They've tried to relate this to the formation of banded iron formations, but I have a lot of research on it, by the way, and I'm trying to think about what they say, but the gist of it is I don't really think they connect them all that well. A lot of the banded iron formations are before the Great Oxygen Event 2.4 billion years ago. They're clear back to about the late Archean up until about the Great Oxygen Event and probably continuing. So a lot of these banded iron formations occurred before the so-called Great Oxygen Event. By the way, in our scenario, we don't have anything like this at all. And there's a question of when the banded iron formations formed. Were they early in the flood or are they pre-flood? And flood geologists have different opinions on them, but no one's done any real good research one way or another on it. So it remains a area of research and semi-controversial within creation geology. So that's the status of banded iron formation. But from the secular point of view, they mostly occurred before the Great Oxygen Event of 2.4 billion years ago in their scheme.
I appreciate it, Mike. That's a great answer. George, did you want to either add anything or pick out the next question here as we kind of
I was just weary of the time for Mike. How are we going for time, Mike?
I have company in 15 minutes. Sorry, I'd love to go for a couple more hours.
I got to say, Mike, time always flies by with you, and we always look forward to having you on as a guest. You're a wealth of information. So
thank you.
We'll then start winding down for, let's say, the last 10 minutes. So you at least have 5 minutes to relax before your company. So George, I'll grab the next question then. And if you want to,
I had my eye on one. So
sure.
This one comes from Chris Peacock. It says, if we lived with dinosaurs, why don't we see tool marks on their bones where we've butchered them? We see tool marks on mammoths and other megafauna. So that's his question.
Well, I think it's, I wouldn't live with dinosaurs, would you?
No.
No.
So buried by ecosystems. I think that probably humans, my guess, it's a guess, educated guess. By the way, that's a technical weather term, by the way, that I've used for 30 years of weather forecasting. Is that man and many mammals lived at higher elevations, or probably in areas far from where dinosaurs lived. So that's the way I explain it. So buried by ecosystems, dinosaurs and marine reptile areas, buried in together with little else. Although there's birds and some mammals and other types of creatures related.
Yeah, I wouldn't want to be living next door to a family of Tyrannosaurus Rex. And correct me if I'm wrong, Mike, don't we have evidence for this in the Bible when it comes to the Garden of Eden and how we have rivers flowing out of Eden?
Yes.
So we have evidence for different elevations and therefore different ecosystems where we would have dinosaurs, certain groups of dinosaurs living in a different ecosystem than humans.
Yes.
Yeah. I think a lot of uniformitarians, they look at ecosystems today and then also think that's how it was in the pre-flood world. You know,
the pre-flood world, I think, was pretty unique. First of all, the geography and topography was a lot different than today, and it was a warm climate, mainly because you had at least 10 times as many plants that give out water vapor. So, I mean, there's lots of things that were different, and I'm really interested in what the geography was like, but I just don't know.
Well, everything would have been recreated during the flood.
Oh yeah, and
I mean, even the continents were split apart, so there's a lot of difference to what the original creation looked like.
Oh yeah, just different geography and topography.
Well, completely, the real estate was completely reorganized and changed.
Oh yeah.
So this question here is an important one, and a question a lot of people have, including creationists, especially new creationists that are just getting into this. And the question is, Mike, can Noah's flood explain the formation of canyons and valleys?
Oh yeah, easy. Remember that slide I showed in this presentation about the formation of water gaps?
Yes.
Well, it would work the same way for say where you didn't have a ridge and you had generally different terrain, and you channelized, and it was a powerful current, maybe going 100 miles an hour, and cut down rapidly, forming a canyon and valley rapidly. So yeah, they can form during the channelized flow phase of the flood, the last part of the flood, channelized, forming valleys and canyons and water gaps formed during that, and plus a lot of other features formed at that time. You can learn more about it on my website or the book, How Noah's Flood Shaped Our Earth. I have some on it. And then I have more publications on it too. So yeah, no problem for valleys and canyons formed rapidly late in the flood.
I appreciate that.
Mike,
actually, if I could say one thing, George, because I wanted to point out that I appreciate Mike when he says that oftentimes where there's an apparent challenge to the creationist model, and correct me if I'm wrong, Mike, you'll point out that once you look into it and really research it, you'll find that it's also a challenge for the secular models in the secular camp.
Often I find that. And like I said, 50% of the time, I'm just I'm guessing I can find a reasonable possibility within flood geology or the post-flood rapid ice age.
Amen. Amen. Exactly. George, I apologize. Go ahead, brother.
You're fine. Mike, I'm surprised that even say in Mars, where we find canyons that are multiple times larger than
Yep.
the Grand Canyon, they admit to, a water type biblical narrative caused
Yes.
it on a planet with very little water, and then the whole story changes when it comes to the canyons on Earth. I mean, that's total hypocrisy from my point of view.
Oh yeah. And besides, by the way, the floods on Mars is one of my big topics. I hope to finish up for the International Conference on Creationism. So I've been doing a lot of work on that, and still doing research at the moment.
One of the 500 that you're working on.
Well, 500 years worth of research left to go is what I tell people. So I wouldn't mind people stealing my ideas either. They can steal them. I have plenty of them to give out.
Well, I appreciate all the work you're doing and all the projects, because I really enjoy reading and looking through your latest articles, watching your presentations and lectures. So I appreciate all the work you do.
Oh, you're welcome.
What we'll do is we'll end with this final question, and then we'll wrap it up. But Mike, and again, I really appreciate just how generous you are with your time with us, because this is your 4th time here, and
no problem.
So much information to kind of digest. And we've had a great audience today with so many great questions. So I want to thank everybody for really getting involved and giving us and sending in your questions for this. So here's the last question we'll get to today. This one comes in from Praise I Am's Bible Community. He says, how long does it take for fossils to be turned into fuel? And does that pose a problem for YECs?
Fossils into fuel. Plant fossils become coal, and oil is especially made out of marine algae and some plants. So you don't really, it's not exactly fossils necessarily, but it can form rapidly in the flood, because what do you need for coal and oil? You generally need heat. And oil has to move and be trapped in porous sediments like some dolomites, sandstones are porous. And so when they drill, they look especially for these certain things, which has nothing to do with evolution or creation or flood or uniformitarianism, I might add. We can form these rapidly by piling sediments thousands of feet thick. Remember, when the waters ran off, it eroded. I finally discovering this. Approximately 5,000 feet of sediment average got eroded from the continents. And so you had 5,000 feet up there. I mean, you have plenty of sediments to compress the plants from coal and to heat up the oil. It takes heat and pressure, and we have that during the flood.
And also, Mike, to actually trap the oil, you need a cap layer. You can't wait around millions of years for a cap layer, a shale, to be deposited above that sand layer. Trap. So the flood model better explains the formation of oil because of the heat, the pressure, the overburden that's needed to cap it.
Mm-hmm.
And of course, we've all said that if it's been billions of years, then surely that oil should have cracked and exposed itself into the surface over those years. Because under that kind of pressure, it would never last that long.
That's another problem with the secular view. When you look into it, the secular uniformitarian / actualism view has numerous problems, I find. Numerous problems. But you have to dig deep in the literature to find out, because a lot of times they can present a really good case to people that are unaware of how they can do this. And so a lot of people have lost their faith over these earth science challenges. But like I said, a lot of them, we do have answers for many of them right now, and we're working on answers to some, and further research down the road will even answer more.
Well, I think that's why your answers and your work are just so effective, Mike, because as you were pointing out earlier, you're doing your best to stay up to date on over 50 journals and, you know, all these peer-reviewed papers coming out that you can find really just the best information to oftentimes counter the secular model. So that being said, 2 hours has really flown by as always, Mike. George, thanks for being here as well. Thank you to the audience for so many great questions. It's been a blast. I'm definitely going to rewatch this and, study and digest a lot of this information as well. Mike, any final words before we shut it down?
I think I just had the final word.
It was a good final word, brother. So you've earned a night off now. I really appreciate it as always, Mike. George, I appreciate it as well.
Yeah, Mike's been a fantastic addition to the channel. Mike, personally, and I know many others in the stream would probably like to hear an extended version of your model for the Grand Canyon Formation. So if you don't mind coming back again with that air presentation you mentioned,
okay.
I'd really be thankful for that if you could. Okay,
I'll give you the long version next time.
Yeah.
Awesome. That would be awesome. I really look forward to that. So that being said, everybody, God bless you all. And
enjoy your dinner, Mike.
Okay. Thank you.
God bless.
Bye to everybody. Thanks for the questions.
All right.
My pleasure. Bye-bye.
Bye, Mike. Bye.